Welcome back. Today we're going to talk about the division properties of exponents. So if you go ahead and take a look at the first one, I've got 4 to the 5th divided by 4 to the 2nd. And if I am going to figure this out using expanded form, I'm going to expand the top, expand the bottom. And so because this is division, if you think about it, 4 divided by 4, well, that's equal to 1. And so if I can cancel out some of my 4s, then you can see how many you have left over, right? So 4 divided by 4, I'm going to cross that out because that's actually 1. And 4 divided by 4 is 1. I'm going to cross that out. And if you look, you have 3 left over. So I have 3 factors of 4. And now this answer I can actually write as 4 to the 3rd. So let's go ahead and take a look at the next one. The next one says x to the 8th times x to the 4th. So let's expand the top. X to the 8th means I'm multiplying x 8 times. So I've got 1, 2, 3, 4, 5, 6, 7, 8 x's over 4 x's. So I've got 1 x times x times x times x. And then if I start canceling some out, well, that is equal to 1. X divided by x is equal to 1. X divided by x is equal to 1. X divided by x is equal to 1. And so how many x's do I have left over? I have 4 x's left over. And then I can rewrite that as x to the 4th. Let's try the next one. I've got x to the 4th times y squared. So that means x times x times x times x times 2y's over x squared times y. So I've got x times y. And because the x's represent the same number, I can actually cross out 2 of them because those represent 1. And remember, 1 times anything is itself, which is why I'm not writing the 1s. And then I can cross out 1 set of y's because y divided by y is going to be 1. And so what I'm left with is I'm left with 2 x's and 1 y. So I could rewrite it as x squared y. So now let's just go ahead and take a look. Just like with multiplication, we are doing something with the exponents, right? So here my exponents in the first one were 5 and 2. So if you think about subtracting your exponents, 5 minus 2 gives me 3, right? So I am left with 3, right? And it's subtracting because really what we're doing is we're canceling some of them out, right? So here I had 8 and 4. Well, 8 minus 4 is 4, right? So I could just take my exponents and do 8 minus 4, and I'm left with what the exponent is, right? So in the next one, go ahead and look at your exponents on x. Your exponents on x were 4 and 2. Well, I just do 4 minus 2, and I'm left with 2 x's. Well, then with y, on y, I had 2, so it's just 2 minus 1, and I'm left with just 1y, right? So now I can come up with my rule. It works when you're dividing powers. If they have the same base, all you have to do is subtract your exponents. So we're going to write subtract the exponents. So let's go ahead and try some without doing it in expanded form. Okay, so here I've got m to the 9th over m to the 5th. So if you think about it, I'm going to have 9 m's on the top, 5 m's on the bottom. If I just subtract 9 minus 5, I'm going to be left with 4. So this one just becomes m to the 4th. Go ahead and try the next one on your own. Go ahead and stop the video. Try the next one on your own. Okay, you should have gotten a to the 3rd, b to the 6th. Don't forget that the one at the bottom actually has an exponent of 1 on it. All right? Now let's do 4c together. If you take a look at 24k to the h squared over 6h, well, 24 and 6, let's just take a look at that. 24 and 6, those are not exponents. This is just division, right? So 24 divided by 6 is just 4. Or you could look at this like it's the improper fraction, 24 over 6, and you could reduce it to 4 over 1. But remember, that 1 on the bottom, isn't really necessary. So what I have here is 4. You actually divide your coefficients. The k, I don't have any other k's, so that k stays there. And then when I do h to the second over h, well, the exponent 2 minus 1 is 1, so I'm just left with h. So everything in my denominator completely cancels out, so I'm just left with 4kh. Let's take a look at 4d. 12 over 18. If you feel like you can stop the video and try this one on your own, go for it, okay? 12 over 18. Now I can't do 12 divided by 18 and get a nice pretty number, so we're going to look at 12 over 18 like it's a fraction, 12/18, and we're going to reduce it. So 12 and 18 are both divisible by 6, so then we can do 12 divided by 2 is, or 12 divided by 6 is 2, and 18 divided by 6 is 3. So 12/18 is 2/3. So we're going to write it as 2/3. Now we still have some exponents, some variables with exponents on it. So we're going to go ahead and subtract the exponents on the w's. Now if you think about it, w to the 4th over w to the 4th, everything there is going to cancel out. If you subtract your exponents, you get 4 minus 4, which is 0, which means you have 0 w's. So the w completely cancels out. And then, v to the 6th over v to the 3rd, well, subtract 6 minus 3, and you're left with 3 v's. So I have 2v to the 3rd on the top over 3. You can write this as 2/3 v to the 3rd. However, I like to keep things as one big fraction. Okay, this answer is still correct, but I like this answer better. Okay, let's take a look at the next one. Now don't freak out that the next one has a negative exponent, because we're just going to follow the rule. We subtract the exponents, and it's always the top minus the bottom. So be careful with this. We're doing 3 minus -5. So think about 3 minus -5. 3 minus -5 is really 3 plus +5. So that is 8. So I get c to the 8th power here. Okay, now letter F, we just take a look at it. Again, think about the rule. The rule is subtract the exponents. So I'm just doing n minus x. So I'm going to rewrite this as h to the n minus x. Now letter G, remember, the rule is you can subtract the exponents if you have the same base. The base of the a is m and k. This one, we can't subtract those exponents because they don't have the same base. So we're going to say that this one is already simplified. Now you could rewrite it as m over k in parentheses to the a power, because they have the same exponent, which kind of leans into what we're going to talk about next. So this is talking about the power of a quotient, right? So it's like a division problem or a fraction being taken to a power. So just think about this. If I have 2/3 to the 3rd power, what that means is I'm doing 2/3 3 times. So I've got 2/3 times 2/3 times 2/3. So I have 3 factors of 2 in my numerator, and I have 3 factors of 3 in my denominator. So I could rewrite this as 2 to the 3rd over 3 to the 3rd. And of course, if I was asking you to simplify this, you would have to tell me that that's 8 over 27. Okay? The next one, let's say I've got 4 over m squared. Well, this just means I'm doing 4 over m times 4 over m. And if you look at your numerator, well, you have 2 4's in the numerator, and you have 2 m's in the denominator. So I could rewrite that as 4 squared over m squared. Okay? The next one, I've got y over x to the 3rd. So that just means I'm doing y over x times y over x times y over x, right? So if you look in the numerator, I just have 3 y's. In the denominator, I just have 3 x's. So that could be rewritten as y to the 3rd over x to the 3rd. So now look, how am I getting from this column to this column without having to do it in an expanded form? It's very similar. than what we did when we're taking a power to a power. When you have a quotient raised to a power, you do the same thing. You just bring the exponent in, but you have to remember to apply the exponent to all the factors on the top and all the factors on the bottom, right? So you apply the exponent to all factors in the numerator and denominator. And you can say on the top and the bottom if that's easier for you. So in the numerator and denominator. Now let's go ahead and take a look at some examples. All right, so just a quick reminder, when you have variables or numbers without exponents on them, you can imagine that there are these imaginary little ones on them. So what I'm going to do is I'm going to apply the exponent to the m and the exponent to the 2. So what I end up getting is m to the 5th over 2 to the 5th. But I don't want you to leave it like that. I want you to figure out what 2 to the 5th is. So if I do m to the 5th over 2 to the 5th, well, 2 to the 4th is 16, and so 2 to the 5th is then 32. So you get m to the 5th over 32. Now let's take a look at the next one. You have to apply that 3 now to everyone. Imagine that there's a little imaginary 1 on the 3, the a, and the d, right? So now, when I bring this exponent in, it's got to go on the 3. So again, remember, when you're bringing an exponent from the outside in, you're multiplying exponents. So if there's an imaginary 1 on that 3, 1 times 3 is 3. So what you're doing is 3 to the 3rd power. A to the 3rd power, b to the 9th power, because 3 times 3 is 9, over, looking at the bottom, c to the 12th power, because 4 times 3 is 12, and then d to the 3rd power. And then again, we don't want to leave 3 to the 3rd power there because we know what that is. That's 27. So my final answer is 27, a to the 3rd, b to the 9th, over c to the 12th, d to the 3rd. All right, now I want you to try 5C and 5D 100% on your own and then come back to me. So stop the video right now and try them. So there are the correct answers. Notice in 5C, I did put in the interim step there. You don't have to write that step. If you want to go straight from the problem to the answer here, that is totally fine with me. All right, now let's take a look at the next set of problems. All right, for this next set of problems, I want you to notice that if I am going to simplify this, the x's have the same base, so I would subtract my exponents and get 6 minus 9, which is actually going to give me a negative number. I don't want a negative exponent in my answer. In fact, we are going to talk about negative exponents in the very near future, but not today. So here's what I want you to think about. If you notice, I've got 6 on the top and 9 on the bottom. We're going to go ahead and expand this and just see what happens, right? So on the top, I have 2 times 6 x's on the top. So x times x times x times x times x times x. And then on the bottom, I have 9 x's. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Now think about what we did when we were in expanded form. The x divided by x is 1. So we're actually going to cancel out a total of 6. And what I have left is I have 3 x's on the bottom. Those have to stay on the bottom. They're in the denominator. So this is a fraction. So my final answer, on the top I have a 2. On the bottom I have x to the 3rd. So my answer is 2 over x to the 3rd. Now let's go ahead and take a look at 6b. Go ahead and expand it, right? So I've got on the top a 10 times 3 x's, so x times x times x, times 2 y's, so y times y. On the bottom I have a 5 and 4 x's, x times x times x times x, and then on the bottom, I've got 5 y's. 1, 2, 3, 4, 5 y's, okay? Now, again, reminder, the 10 over 5, we're going to reduce that. That's 2 over 1, but we don't need the 1 in the denominator. We just have so we just have a 2 in the numerator. And so now we can cancel out my x's. So I cancel out 3 total x's, and I cancel out 2 total y's. So I have no variables on the top, but I have 1 x left over at the bottom, and I have 3 y's left over on the bottom. So that's 2 over xy to the third. Okay? So the rule of thumb here is everyone should just pay attention. If you have more variables on the bottom than you do on the top, when you subtract, you're going to end up with that number in the denominator, right? Or you can even think about it, if you're going to end up with a negative exponent, you have some left over in the bottom, okay? So just think about canceling things out. Here you had 3 at the top, 4 on the bottom, and then you had to cancel out all 3 on the top, you're left with 1 on the bottom. Here you had to cancel out the 2 on the top, and you're left with 3 on the bottom, right? So you're taking 2 away from the 5. But notice, because there are more on the bottom, the final answer has your exponent on the bottom. So now go ahead and try the next 2 on your own. You can either try it with expanded form, or you can just try to do it in your head. So stop the video, try the next 2 100% on your own, and then tune back in. Okay, so let's see how you did. Reminder, we are going to leave these things as one big fraction, right? So the 2 8s, they're not exponents. You don't subtract them. You reduce the fraction 2 8s. So I reduced it to 1/4 here. And then my a's, look, I have 4 a's on the top and 6 a's on the bottom. So I have more on the bottom than I do on the top. So if I cancel out the 4 up here and 4 down here, I'm left with 2 on the bottom. And then I've got 6 here and 1 here, and I'm left with 5 on the top. So notice there were more on the top here, so it stayed on the top. Now my final answer does not include that 1, because 1 times b to the 5th is just b to the 5th because of the multiplicative identity property, right? So this would be my 100% simplified version, all right? Now the next one. Notice here that you have negative 6 over 4. That is an improper fraction. Do not change this to a mixed number, because what we want, this is one big fraction, we are going to leave it just as one big fraction. So we're going to treat this like negative 6 over 4. We're going to leave it improper. It reduces to negative 3 over 2. Do not make that negative 1.5. Okay? Now, up at the top, we have an x, and down at the bottom, we have x to the 9th. So we have more x's on the bottom. The 1 at the top cancels out. You're going to be left with 8 on the bottom. And then we have more y's on the top than we do the bottom. That counts as 1. You're taking 1 away from that. You're left with 6 on the top. So basically, if you have more on the bottom, your variable stays on the bottom. If you have more on the top, your variable stays on the top. We do not change improper fractions to mixed numbers. We just leave it like that, and we leave it all as one big fraction. All right. Go ahead and try to finish the rest of the problems for homework. And if you're struggling with anything, please make sure you ask.